Hello friends, in previous three videos we have learned about the Euclid's algorithm lemma, about finding HCF and LCM by price factorization method, and we have learned about proving that given number is an irrational number. Now we will learn the fourth topic of the first chapter, the last topic, and this topic you have learned in standard 9, that to convert the rational number in the decimal expansion. So any rational number may be in form of, if you write the decimal expansion of any rational number, it may be terminating decimal. I will write it as TD in short. So whenever I will write TD, you have to assume that it is a terminating decimal. And second is non-terminating and non-terminating repeating. Non-terminating repeating decimal. It can be abbreviated as NTRD. So whenever I write NTRD, you have to think about non-terminating repeating decimal. Now any terminating decimal must have factors 5 or 2. Okay, they have factors 5 or 2 in denominator. Okay, it must have, or it has, I will remove must, right? It has factors 5 or 2 in denominator. So if you find 5 or 2 or both, 5 or 2 or both in denominator, you have to write that it is TD. And if you find factors other than 2 and 5, right? If you find the factors other than 2 and 5, you have to write that it is NTRD. Okay? So this is the concept on which we have to complete exercise 1.4. Now exercise 1.4, question number 1. State whether these numbers are terminating decimal or non-terminating recurring decimal without use of long division. So the first term, that is 13 upon 3125. Now 3125, as you know, 3125 is 5 raised to 5. 5 raised to 1, that is 5. 5 raised to 2, 25. 5 raised to 3, 125. 5 raised to 4, 625. 5 raised to 5 is 3125. So friends, here we have denominator in form of 5. So I will write here denominator has factor 5. So it is TD, an easy sum. Okay, nothing hard. Now second one, that is 64 upon 455. Now 455, we don't know the factors of 455. So what we have to do? We have to factorize it by prime factorization method. Here we have unit digit 5, so it must divisible by 5. 5 nines are 45, 5 ones are. Now it is divisible by 7, 7 ones are 7, and here we have 2 7 3s are and 13 ones are, right? So I can write here 64 upon 5 into 7 into 13. So here we have more the factor other than 5, so we can say that it is not a terminating decimal and hence it is NTRD, yani ki non-terminating recurring decimal. So I will write here denominator has factor other than 5, hence it is non-terminating recurring decimal. So very easy sums they are. Here we can see that it has factors 2, 5 and 7. Okay, so here we are given already factorization form, so we don't have to factorize it again. So here I can say that here denominator is not denominator has factors other than 2 and 5. So it is non-terminating recurring decimal. Okay. Now, so you will surprise why sir has taken this simple sum. So if I write here 15 can be written as 5 into 3. So you will think that here we have a factor other than 5. So it is non-terminating recurring decimal. But you are wrong. Why you are wrong? Because here the 6 can be factorized as 2 into 3. Now I can cut 3. And now I can say that the simplest form of the number is 2 by 5. So friends, you must remember that in every sum, you have to think if any factor is common in numerator and denominator. If so, you have to cut them and then you have to think about it. Okay, so now here we have denominator in form or denominator has factor 5, so it is terminating decimal. Now the last one, that is 77 upon 210. So 77 upon 210. So this can be factorized as 7 into 3 into 10. And 10 can be factorized as 5 into 2. So the factors of 210 are 2, 3, 5, 7. Okay, here as I have told you earlier that you have to think whether any factor is common or not. So here we can say that 7 is common, so I can cut 7. So in denominator I have 2 into 3 into 5. Okay, now you can say that it has factor other than 2 and 5, so it is non-terminating recurring decimal. Okay, so in this way we can complete question number 1. Now we will do question number 2. Now friends, we will do question number 2. Write decimal expansion of rational numbers in question 1 which have tilde. Now the first I have chosen 3 of them, as you can do it yourself. Now 13 upon 3, 1, 2, 5. So 3, 1, 2, 5 can be written as 5 raised to 5. Now instead of dividing it, it is a tedious job. So instead of dividing it, what I will do, I will have a concept of 5 into 2 is equal to 10. Similarly, if I have 5 into 2 raised to 2, I have 10 raised to 2. And similarly, I can write here, if I have 5 into 2 raised to n, then the number will be 10 raised to n. So whatever the power of 5 will be equal to power of 2. So I have power of 5 as 5. So I will multiply it with 2 raised to 5. I will multiply it with 2 raised to 5. So in numerator I have 13 into 2 raised to 5, that is 2, 2s are 4, 2s are 8, 2s are 16, 2s are 32. So it is 13 into 32 upon 5 raised to 5 into 2 raised to 5. I will take the power common. So I have here 5 into 2. Now I can multiply it with 13. 13 2s are 26, carry over 2. 13 3s are 39. 39 plus 2, that is 41. And here I have 10 raised to 5. So 10 raised to 5, that is I have 5 zeros after 1. So that now I can write 416 upon 5 zeros. Now friends, you know that if you have zeros in denominator, you have to cut that much point from the numerator and you have to move from right to left. I have here 5 zeros. So I have to move 5 digits back. I have first digit 6, second digit 1, third digit 4, and the fourth and fifth digit are not given. So I will write there 0, 0, and point I have written 0. So my answer will be 0.00416. Right? Now the second one, that is 17 upon 8. Again 8 is given, so I can write it as 2 raised to 3. Now with which term I should multiply? You know the answer. I will multiply it with 5 raised to 3. I will multiply with 5 raised to 3. So I have 17 into 125 upon 5 into 2 raised to 3. Okay, I have taken this power common. Now 17 5s are 85, carry over 8. 17 2s are 34. 34 plus 8 it is 42. Carry over 4. 17 ones are 17. 17 plus 4 21. In denominator we have 10 raised to 3, that is I have to write 3 zeros after 1. Now I have to cut 3 points. 1, 2, 3. So 1, 2, 3. I have to put here points. So my answer will be 2 points. 1, 2, 5. And the last one that I have told you 6 by 15. I have cut the factor 3 from numerator and denominator. So I have left 2 upon 5. Here simply I should multiply with 2. I have 4 upon 10, that is 0.4. The other sums you can do it yourself. Okay? Now we will do question number 4, the last question of the exercise. Decide if they are rational or not. If the number is given rational and of form p by q, what you can say about q? So first of all, we have the first number as 43.1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can see that there is no dot 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 here, so it must be a terminating decimal. So I can say that it is a TD. And as it is a TD, I can say that it is a rational number. Any terminating decimal is always considered as a rational number. Now, what I have to think about q? We have to find what you can say about q. Now, it is a terminating decimal, so we know that q must have factors 2 or 5 or both 2 and 5. Okay, it must not have any other factor than 2 and 5. Okay, so it is completed. Now the second one, we have a number 0.120, 1200, 12000, 1200000 dot 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 dot. So here this number is non-terminating, non-recurring. It is non-terminating, non-recurring decimal. It is NENRD, that is non-terminating, non-recurring decimal, and hence it is an irrational number. And we know that any irrational number cannot be written in form of p by q. So here we can't say anything about q. Now the third one, this number is non-terminating recurring decimal, as we have a bar here. So these digits will repeat. So it is called non-terminating recurring decimal. And as we know that the non-terminating recurring decimal, the q must have factors other than 2 and 5, because 5 into 2 it is 10. Okay, so q must have factors other than 2 and 5. So here we have completed our chapter number 1, that is real numbers. I hope you understand it properly. Thank you.